everybody and welcome to my YouTube channel. I'm Michael and this video is about building a little puzzle made out of common 360 brass and a holder for the pieces when the puzzle is disassembled. Here's your Fusion 3D model of the design. And this is the holder. The only critical dimension for this project is the depth of these cuts. They're nominally half the diameter of the cylinder. The cylinder is 5 1/8, so the depth of cut should be 5/16. If that is less than that value, the cylinder here might not slip in, and if it's more, the whole thing will wobble. So I shoot for 2/1000 of an inch deeper cut, and we dial that in with a process called cutter compensation or tool wear. I'll get to that as soon as we move to the manufacturing or CAM environment. Here again in a drawing, that's the cylinder. This is the connecting part. So the combined depth here, or the combined dimension, is 16th of an inch. That is 0.9375. And we're shooting for a little bit less, something like 0.935 or 55, 2/1000 less. Okay, a switch to the manufacturing or CAM environment. This is the setup for these two cuts. 5 of the 6 parts receive these 2 cuts. 2 parts receive an additional cut. So this is the simulation. I take baby steps here because this part sticks out pretty far and I'm a little bit worried about chatter, so baby cuts. Time is not of the essence here. So we're done here. The next operation is for dialing in the final depth of cut of these pockets. I use cutter compensation or tool wear for that. That means the calculation of the final tool path is handed over from Fusion to PathPilot, meaning that I can do that directly at the machine. I don't need to change the model. It's a very simple operation. Just a circular operation. I recut this and then I take the measurement, and depending on the measurement, I change the tool diameter in PathPilot and repeat this step until I reach the dimension I want. Very elegant, I think, very elegant method, and saves a lot of time running back and forth to your computer, changing the model, creating a new CNC file, and so forth. I do that measurement for one pocket and just trust that it's going to be the same for all pockets. The next operation is very similar to the prior operations. In this, we cut the third pocket for 2 parts, and then again dial in the dimension with the cutter compensation method and the cutter dimensions we found when we measured it with the very first pocket. The 6th cylinder does not get any pockets, just a 1 1/8 inch hole for a little steel pin later. And finally, the wooden block or holder for the pieces when the puzzle is disassembled. First we face it off, then we pre-drill holes, then we bore out those holes with a little bit more than 5 1/8 so that the pieces slide in easily. Finally we chamfer everything. We're done. The puzzle consists of 6 pieces, all of equal length of 5 inches. 3 pieces have 2 pockets, two pieces have 3 pockets and one piece has no pocket but a little pin. So what we're going to do here, we CNC mill out these pockets and we drill the hole for the little pin. Okay, first part is work holding. I turned 6 of those cylinders made out of brass 360 on my lathe. Diameter is 5 1/8, length is 5 inches, and I'm going to hold these with a 5 inch collet and a collet block in my vise on the CNC mill. I marked the stick out of this part with a little pencil mark here and move that in to this mark. The stick out is defined by the cuts I need to make, but also need some freedom for the lead in of the cutter. And then I pop that into the collet block. And since I only want to set the work origin once for all 6 parts, I use one of these end stops. The way they work, you just screw that part in, secure it here, and then you set the end stop, secure that, and now I can indicate this portion of the part as my work origin, and in Z-axis the work origin will be the top of the cylinder, and that way I can take out this block out of my mill vise, because as long as it's in the mill vise I cannot access this wheel here. You can take it out, put it in the vise, put in a new part, and it is very repetitive. So it's always going to be the same work origin. Okay, so I secured the lock nut, and now put it in the vise and align it with the fixed jaw. And then, because I don't like to tighten the vise when the workpiece is only on one side of the vise, I pop in a second block to have equal pressure on both sides. Otherwise I'm concerned that the 2 jaws just move a little bit like that. So now we tighten it and we should be ready to go. The advantage of using this square collet block is we're going to mill these 2 pockets first, and to mill this pocket we just flip the block 90 degrees and we have a perfect right angle 90 degrees between those cuts. Okay, now we set the work origin. Okay, with the work origin set, we cut the first 2 pockets, and this can be done then for 5 of the 6 pieces. And now we measure the thickness of the combined pieces. That should be 5 1/8 and plus 5/16, and we are at 0.956. That means we need to cut a little bit deeper, and for that I created a tool wear or cutter compensation setup, which only cuts once to make it a little bit deeper, and the depth of the cut I can adjust at Path Pilot. I don't need to change the model. So the first pass is I just make the cut 2 thousandths deeper, and then we see where we are. Okay, here we go. This is one of these exercises where you like to have 3 hands. Okay, this is the size of the cylinder. It's exactly 5 1/8. To show you this measurement, I took the part off the mill. It's almost impossible to do the measurement at the mill at an angle where you can still see it on the camera. So the nominal dimension here of the connecting cylinders would be 5 1/8 and 5/16. Altogether would be 15/16 or 0.9375. We want to have a little bit less in order to make it easier for the parts to slip in and out. So I gave it 2 thousandths, and that's exactly the dimension we dial in with cutter compensation or tool wear. This is now the operation to cut the third pocket for the 2 pieces with 3 pockets. And now I cut the third pocket with the same setting I used for the 2 other pockets with my separate setup, where I use tool wear or cutter compensation just to adjust for the final depth of cut. And as with the last cut, I run it again. That should give me exactly the same measurement. Here we go. And that is it for cutting the pockets. Turned out very nice. Okay, the last operation in brass is cutting the hole for the 6th part, which has no pockets, just gets a hole for a little pin later. And that was easy. Okay, and finally we machine the wooden holder for the 6 pieces when they're disassembled. First up, set the work origin. Use my passive probe this time. that sets X and Y. And finally Z. Here we go. So first cutting operation is facing it off with a shear hawk. And I set the lead in and the step over in a way that the cutter cuts inside the material at the edges, here and over here. I'm concerned that if it would cut outside, that I create some splintering here. Next operation is to pre-drill the 6 holes with a 1/2 inch drill. Next step is to bore out these holes to 5 1/8 inch and 5/1000 over to give us a little bit play that the pieces move in more easily. So a quick check. You hear the plop? Beautiful. And the final operation is chamfering the 6 holes and the corners. And that is it. And here is the final result, disassembled in its holder. And that is the puzzle assembled. See, it doesn't wobble. So these tolerances between the cuts and the cylinders are tight, but they still slip in easily. Alright, that's the end of this video. I hope you enjoyed it. I don't want to spoil the game at this point, how to assemble the puzzle. If you can figure it out, I'm going to have a separate video just for the solution of this puzzle in my next video. Thank you very much, and I hope to see you soon.